All right, so we're going to take a look at exact values of trig ratios. And exact answers involving radicals are exact, unlike approximate decimal values. So, for example, a fraction like 1 over 3 is exact, but the approximation of 1 over 3, which is 0.333, is not. We're going to take a look at angles of 30 degrees, 45, and 60, and we're going to take a look at how we get those exact values for those trig ratios. The first one we're going to take a look at is 45 degrees, and the way we're going to work this out is by drawing the diagonal of a square with a side length of 1 unit, because what it will do is give us a 45, 45, 90 triangle. And this is an isosceles right triangle. Okay, isosceles meaning that two of your sides are the same and one of your angles is 90 degrees for the right angle. Okay, all right, so we're going to take this isosceles right. Originally it was a square, okay, where all of your side lengths are 1 and all of your angles were 90 degrees. When you draw the diagonal through this square, you are cutting the square in half. You are bisecting both of these angles. So instead of 90 degrees, you now have a 45 degree angle here, and there's one over here also. Okay, and here. Okay, so really what you've done is you've formed two isosceles right triangles. Now, the side lengths we made 1, and now we have a hypotenuse, okay, and we need to figure out the value of what C is. So, right triangles, we use Pythagoras' theorem to find missing sides on, and we want the hypotenuse, so we're going to take our theorem and we're going to rearrange it so that it reads C squared equals A squared plus B squared instead of A squared plus B squared equals C squared. And that's because we want to find out what C is. Okay, so A and B can be either of the two legs of our right triangle, and so I'm going to replace A with 1 and B with 1, so that gives us C squared equals 1 squared plus 1 squared, so C squared equals 1 plus 1, and C squared equals 2, and so we take the square root of both sides and we get that C is equal to root 2. Now, we don't want to calculate the value of that because this is an irrational number, and as soon as I get the decimal form of this, it's no longer exact. So this is an exact value. Okay, so we want to work out the trig ratios for this particular triangle. And if you recall your trigonometry from last year, you know that sine of theta is opposite over hypotenuse, cos of theta is adjacent over hypotenuse, and tan of theta is opposite over adjacent. And I think you would have learned SOHCAHTOA to help you remember those ratios. Okay, so sine opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. Okay, so we're going to come up with exact values for these trig ratios. Okay, now we're looking at 45 degrees. And so we want the sine of 45 degrees. That's equal to the opposite. Well, the opposite side to 45 degrees is 1. And so we go 1, and then our hypotenuse we know is root 2. And so we say 1 over the square root of 2. Okay, our next ratio, cosine, we want the cos of 45 degrees. That's adjacent. So the side adjacent to the 45 degrees is also 1 because we have an isosceles right triangle. And so we put 1 over our hypotenuse, which is square root of 2. All right, and then the tangent of theta, and in this case the tangent of 45 degrees, is opposite over adjacent, so opposite being 1, adjacent being 1, so 1 over 1, and so the tangent of 45 degrees is equal to 1. Okay, so these are exact ratios for sine 45, cos 45, and tan 45. And notice, because we have an isosceles right triangle, our sine and cosine of 45 degrees are both 1 over root 2. Okay, you need to remember these. So probably the best way to do that is to memorize the triangle. Okay, so let's take a look at our two other angles, which are 30 degrees and 60 degrees. The way we get this, the trig ratios for this, is by using a 30, 60, 90 triangle. And the way that we come up with our ratios for this is we start with an equilateral triangle. So I'm just going to draw this so that it's equilateral. Okay, and remember, equilateral means that all of your sides are the same. And because we have a side of 2 on here, on this triangle, we have a side of 2 here and a side of 2 here. And remember, in an equilateral triangle, all of your angles are 60 degrees. Okay, so by taking an equilateral triangle and drawing an altitude into it, okay, going from the top vertex down to the base at a 90-degree angle, we formed the height, okay, and it also bisects the triangle, okay, it cuts it in half. So when we do that, the base, which was originally 2, now for half of your triangle is 1, and the other half is also 1, right? 1 plus 1 is 2. And also this top angle here gets bisected, so what is 60 degrees gets cut in half, so we have a 30-degree angle here, and we have a 30-degree angle over here. Okay, and so what you've formed now are two 30, 60, 90 triangles. Okay, so so 30, 60, 90 triangle. All right, so how do we get the height of this triangle? Well, we have a right triangle, and so we can use Pythagoras' theorem to work that out. We know what C is, okay, and I'm going to call this side A, and this is H. So we can use Pythagoras' theorem again. We know that A squared plus B squared equals C squared. I know that A is 1. B I'm going to call H, and C is 2. Okay, so we get 1 plus H squared equals 4. Solve for H squared, so bring your 1 over, it becomes negative. 4 minus 1 is 3. And so H is the square root of 3. And once again, don't work this out as a decimal. This is an exact value. And so we're going to leave it. Okay, so what we want to do with this triangle is we want to find out what our trig ratios are for 30 degrees and for 60 degrees. So let's start with 30 degrees. Okay, so sine of 30 degrees, and then we want cos of 30 degrees and tan of 30 degrees. Okay, now one way to remember which sides belong on, like which ratios belong on which sides of the triangle, is to remember that the smallest side, which is 1, is opposite the smallest angle, so opposite 30 degrees. The next smallest side, root 3, because that's, when you work that out as a decimal, it's 1.73, is opposite the middle angle, okay, the 60 degrees, okay. And then the largest side, which is 2, is opposite the largest angle, which is 90 degrees. Okay, so smallest side opposite smallest angle, middle side opposite middle angle, and largest side opposite the 90-degree angle. Okay, so we want the sine of 30 degrees. Okay, we know that sine is opposite over hypotenuse. And so the side opposite to the 30 degrees is the 1. And so the opposite 1 over the hypotenuse 2 gives us a sine of 30 degrees being 1 over 2. Okay, cosine is adjacent over hypotenuse. So the side adjacent to the 30 degrees is the height of our triangle, which is root 3. Okay, so this is adjacent. And so our trig ratio for 30 degrees is adjacent root 3 over the hypotenuse, which is 2, so root 3 over 2. Okay, exact ratio for tangent is opposite over adjacent, so our opposite is 1, and the adjacent is root 3, so we get 1 over root 3. Okay, so remember, don't change any of those radicals to decimals because they will no longer be exact values. Alright, so now let's take a look at our exact values for sine of 60. Cos of 60, and tan of 60. Okay, so now we're taking a look at the angle, which is 60 degrees. So our opposite side is no longer going to be 1 because that's opposite to the 30. Our opposite for 60 is going to be the height of the triangle, so now this is opposite. Okay, and the adjacent side to 60 degrees is going to be what used to be the opposite, so now it will be the side which measures 1, so this is now the adjacent. Notice the hypotenuse doesn't change. Okay, so sine of 60 degrees is opposite over hypotenuse, so root 3 over 2. Cos of 60 degrees is adjacent over hypotenuse, so 1 over 2. And the tan of 60 degrees is opposite over adjacent, so root 3 over 1, which you can reduce to root 3. Okay, so notice that there's some patterns going on here. Take a look. You've got cos of 30 degrees is root 3 over 2, sine of 60 is root 3 over 2. Sine of 30 degrees is a half, and cos of 60 degrees is a half. Okay, and the reason why they have switched, right, why sine of 30 is the same as cos of 60 is because when you're looking for opposite and adjacent to the 30 and the 60 degrees, the opposite and the adjacent switch. Okay, and notice that your tangent of 30 degrees is a reciprocal of your tangent of 60 degrees. Okay, and that's once again because your adjacent and your opposite switch. Okay, so you do need to remember these. So probably the best way for you to do that is to memorize the 30, 60, 90 triangle. Okay, and that concludes our discussion on exact values.